This is Geometry, Section 3.7, Lines in the Coordinate Plane. So this entire section is pretty much a review from Algebra 1. All we're really going to be talking about today is slope. So the slope of a line, as hopefully you know, is the rise over the run. So we'll talk about what we mean by rise and run. So when we're counting the rise and the run of a line, we look at two different points on the line. When we count the rise from one point to another, counting up means positive, counting down means negative, counting to the right means positive, and counting to the left means negative. So up and down is the rise, and right and left is the run. So, for example, if I have this line right here, if I want to find the slope of that, I count the rise over the run. I just pick any 2 points, so I'll pick this point right here and this point right here. So I count first the rise. So how far up or down do I have to go to get from this point to this point? So I count up 1 unit. So that's my rise. So my slope is going to be 1 over my run, which is 2 to the right. And we said to the right is positive, so that's 1 over 2. Same thing here, pick 2 points. So I'll pick these 2 points. Now if I count from this point to this point, my rise is going to be going down 1, 2, 3 units. So that's going to be a negative 3 over, I'm counting to the right, 2. So a negative 3 over 2. Here, I'll pick these 2 points. So my rise is going to be positive because I'm going up 1, 2, 3, 4, 5. So my rise is going to be 5 over my run, which is going to be 1, 2, 3, 4. Here, same thing. We'll pick these 2 points here and here. So from this point to this point, my rise is now down 1, 2, 3. So a negative 3 over 1, 2, 3, positive 4. We could also count this one if we counted the opposite way. So if we went from this point to this point, I would count up 1, 2, 3, but then I would be counting to the left 1, 2, 3, 4. So that would be a positive 3 over a negative 4, since I counted to the left 4. So positive 3 over negative 4 is the same thing as negative 3 over positive 4. It's negative either way you look at it. For this next one, this is a horizontal line. So if I pick any 2 points, anywhere on this line, my rise is going to be 0. So no matter what I count my run as, my rise is always 0. So my slope for a horizontal line, the slope is always going to be 0. Similarly, for a vertical line, if I pick any point, any 2 points that I pick, the rise is going to be something different. So if I pick these 2 points, it's going to be 1, 2, 3, 4, 5, 6, 7. But if I pick these 2 points, it's going to be 1. So we really can't tell what the rise is for a vertical line. So for a vertical line, we say that the slope is undefined. So, formal definition of slope. If I have 2 points, x1, y1, and x2, y2, each point has an x-coordinate and a y-coordinate, so we just say x1, y1, x2, y2. So if those are my points, the slope is going to be the difference in the y-coordinates over the difference in the x-coordinates. So I take one y-coordinate minus the other y-coordinate over that first point's x-coordinate minus the other x-coordinate. So if I'm finding the slope of the lines that pass through all of these points here, or each pair of points here. So I've got 2, 3, 6, 15. So first I have to deal with the y's. So here I've got a y-coordinate of 15. Here I have a y-coordinate of 3. So on the top I would put 15 minus 3. On the bottom, my x-coordinates are 6 and 2. And since I started with 15, I have to start with 6. So 6 minus 2. 15 minus 3 is 12. 6 minus 2 is 4. So 12 over 4 reduces to 3. Here, y-coordinates are negative 3 and negative 8. So negative 3 minus a negative 8 over, x-coordinates are negative 5 and 1. Negative 5 minus 1. So a negative 3 minus a negative 8 turns into negative 3 plus 8. Negative 3 plus 8, or 8 minus 3, is 5. and negative 5 minus 1, those are both negative, so that becomes negative 6. So I've got 5 over negative 6, so we just write that as negative 5 over 6. We just move the negative out front. 5, 7, and negative 3, 7. So I have two y-coordinates, both of 7. So when I subtract the y-coordinates, 7 minus 7, that gives me 0. So it doesn't really matter what I get on the bottom, because the top is going to be 0, and 0 divided by anything is 0. So that's my slope. Last one, I've got 1 and 9, so 9 minus 1 for the y-coordinates over the x-coordinates, 4 minus 4. 9 minus 1 is 8, 4 minus 4 is 0, but we cannot divide by 0. That's not allowed. So this is actually a vertical line, and the slope is undefined. So this should look familiar in the slope-intercept equation of a line. Y equals mx plus b. That should look familiar to you. M is the variable we use to represent slope, and b is the variable we represent the y-intercept with. So the y-intercept is the point on the y-axis where x equals 0. So write the equation of the line below using y equals mx plus b. So we have to find b and we have to find m. So b is easier to find looking at a graph than m is. B, we just look where it hits the y-axis. So b here is 10 because it hits the y-axis at 10. Now to find the slope, I've got to take 2 points. So I'll take this point right here and this one next to it. We have to count our rise and our run. So rise is going to be down 2, and then run is going to be over 1. So negative 2 over 1, which is just negative 2. So our slope is negative 2, so we write y equals mx plus b, negative 2x plus, we said b was 10 for our y-intercept. This next one, I've got now my y-intercept is, let's see, this is 5, 6, 7, 8. So this is b equals 8. This is the next closest point, so now I have to count my rise, which is negative 1, 2, 3, 4. So this is in negative 4, and then I'm counting to the left, 1, 2, 3, 4, 5. So since I counted down and left, both of those are negative, which means this is really a positive slope, because a negative 4 over a negative 5 would turn into a positive 4 over 5. So my slope is positive 4 over 5. So y equals 4/5 x plus our y-intercept was 8. This one, my y-intercept is all the way down here at negative 9. So b is negative 9. Then if I count to the next point, my rise is 1, 2, 3, and then over 1, 2, 3, 4. So my slope is 3 over 4. So 3/4 x plus my y-intercept of negative 9. So we could either write this as plus negative 9, or we would probably see that written as just minus 9. Write the equation of the line with, so we've got a slope of 3/7 and a y-intercept of negative 13. So here we don't have a graph, we just have the slope and the intercept, and we have to put it in an equation. So y equals my slope, 3/7 x minus 13, or plus negative 13. Here, y equals, slope is negative 5, x plus my y-intercept of 12. So that's slope-intercept. There's also another form of an equation that we use frequently, and this one is called point slope. So point slope says y minus y1 and m, which is slope, times x minus x1, where m is still the slope, and x1, y1 is a point on the line. So we just pick an x-coordinate here and a y-coordinate here, and notice that it is a minus here, not a plus. Okay, so now we're going to write some equations of lines in point slope form.